All right, let's get into the last section of chapter 5. It's going to be a review of solving equations that we've done in the past chapters, but we're going to be doing it with rational numbers, not just integers. So our learning target is to solve equations with rational numbers. Remember that a rational number is any number that can be written as a fraction. Okay, and that includes decimals that terminate, right, or that have an ending, or decimals that don't end but they repeat. All right, so if you remember the number systems that we got into earlier, the rational includes all natural numbers, right? Our counting numbers 1, 2, 3, 4, 5. Whole numbers, which includes 0, that's also a rational number. Remember, you can make anything a rational number by just putting it over 1. And then we added in fractions such as 1/2. We added in decimals that end, like 2.125, right? There's an ending to that. And then even though this has a dot, 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 meaning it keeps going, or we also looked at that in bar notation, that's also rational, right? Hopefully you recognize that as 1/3. So let's just review our solving equations with integers so we can remember the properties that we used to solve them, right? We use inverse operations, right? So when I look at number 1, it's saying what plus 3 equals 7. Okay, and we should be able to look at that. And you can plug in different numbers, right? I can say, well, what if it's 1? 1 plus 3 is 4. Well, that's not equal to 1 then. I should know that 4 plus 3 is 7. But in more difficult problems, especially when we get into rationals, remember we use inverse or opposite operations, right? So if this is my variable, this is adding 3. So I want to subtract 3 from both sides. So here, right, I'm left with x. 3 minus 3 cancels. 7 minus 3 is 4. So in this one, x would equal 4. Here we have a similar problem, except for it's x minus 4. So what number minus 4 equals 1? Right? So if I split this in half, right? So here's my variable. The opposite of minus 4 would be to add 4 to both sides. And we would have that cancel. We're left with x. 1 plus 4 is equal to 5. So in this example, x is equal to 5. Now, it doesn't matter which side of the equation the variable's on, right? If it's equal, it's balanced on both sides. So I could change that around, right? These two are saying the same things. Or if my variable's over here, leave it. It's what plus 24. So I want to go minus 24. And that cancels here. We're left with just x. Remember, opposite signs, right? A negative and a positive. We subtract, opposite subtract. So 24 minus 19 is 5. Since the 24 is bigger, my answer should be negative, right? So x equals negative 5. Now, just remember that you can always plug these back in and check, right? Does negative 5 plus 24 equal 19? And the answer is yes. So 4, 5, and 6, we're going to look at some multiplication and division problems, right? This is 3x, right? But really it's understood that there's a multiplication sign in between there. So it's saying 3 times what equals 21. We should know our multiplication facts and know that that's 7, but the inverse operation to solve would be to divide, right? Have to do it to both sides, right? And 3 divided by 3 is just 1, so that leaves me with 1x. 21 divided by 3 is 7, so x equals 7 in this example. Number 5, what divided by 4 equals 2, right? And I should know that it's 8. All right, but my inverse operation says if this is my variable and it's divided by 4, to inverse that, I multiply both sides by 4. Right? 4 divided by 4 is just 1, so I'm left with x. 2 times 4 equals 8. So x equals 8 in number 5. Now, those were nice, neat, clean answers, right? We got integer values for all of them. Now, that's not always going to be the case. All right, if I look at number 6, right, here's my 3 times my variable. 3 times what number is equal to 19? Right, well, I know that 3 times 6 is 18, and 3 times 7 is 21. So it's in between 6 and 7. So 3 times x, the inverse of that would be to divide. Right, 3 divided by 3 is just 1, so I'm left with x there. And I have 19 over 3 here. So 19 over 3 is a valid answer, right? Or I could change that into a mixed number, right? 3 goes into 19 6 times, right? 3 times 6 is 18, so that means there's 1/3 left over, right? Or you could plug that in your calculator, and your calculator would tell you 6.3 repeating, right? So any of these are valid answers for that problem. You should be able to work between all 3 of those because if it's a test that's multiple choice, you have to be able to pick the answer that's represented with the multiple choice answers. But for the homework, you can leave those in any form you'd like. All right, so you can see here we're going to do the same types of problems, except for we are just going to use rational numbers. So they're not all nice integers, right? We're going to have decimals, we're going to have some that are fractions. And so we're going to be applying the properties that we learned throughout the chapter of rational numbers. So number 1, here's my variable. It's what minus 8.5 is equal to 2.1. So the opposite of minus is plus. Have to do that to both sides. Right? So negative 8.5 and positive 8.5 cancel. I'm left with t equals, over here we get 10.6. Number 2. Okay, so here is my variable. It's negative 3.1 plus n. Now this one's a little bit confusing because I see this plus sign here, and we might want to minus, but if you think about it, this value here is what we need to cancel out, right? And it's a negative 3.1. So what I want to do is I want to add 3.1 to both sides because that's what would get it to cancel. A negative 3.1 and a positive 3.1 cancel out. That isolates the variable to give me n. And here we would have 10.4 as my value. So n equals 10.4. And remember, you can always take the answer that you get and plug it back in and make sure that it checks out. Number 3, working with fractions here. So here's my variable, subtracting 3.5. So I want to add, sorry, not 3.5, 3 over 5, 3/5. So I want to add 3/5. Now, over here, that would cancel. I'm left with a. So my problem is 2/3 plus 3/5. So this is where our adding and subtracting fractions come into play. They're unlike denominators, right? They are unlike denominators, so I have to make them the same. So I'm going to multiply this by 5 over 5 and this by 3 over 3 because that would give me a common denominator of 15, right? 5 times 2 is 10 over 15 plus 9 over 15, right? So now they're common denominators. I can add them together. 10 plus 9 is 19 over 15, right? And that's okay to leave your answer like that, right? But we should be able to move between mixed and top-heavy fractions, right? So 15 goes into 19 once with 4 out of 15 left over. Either one of those answers would be correct. All right, using subtraction. So notice in each of these, it's my variable plus a number, variable plus a number. Here, my variable plus a number. So in each case, we are going to be subtracting, right? Here's my variable. I'm going to subtract 4/9 from both sides. So we get x here. Right here, I'm going to subtract 3.2 from both sides. Right? Cancels there. So I would have c equals, and on this one, right, I'm going to be subtracting the 1/3 from both sides. And I'd have s, and I got to figure out what that equals. So what I want you to do is I want you to pause the video here and do each one of these subtraction problems, right? So here it's 1 1/3 minus 4/9. This one would be 10 minus 3.2. And this one would be negative 4 1/10 minus 1/3. So take a minute, pause the video, come back and check your work. All right, let's see how you did. In number 1, 1 1/3, in order to subtract, I changed that to 4/3. Common denominator, right? The least common denominator would be 9, so I times this first fraction by 3. I got 12/9 minus 4/9, which gave me 8/9. 10 minus 3.2 should give you 6.8. And then in number 3, I changed negative 4 1/10 to negative 41/10 minus 1/3, right? Common denominator would be, least common denominator would be 30. So I times the first fraction by 3/3, the second fraction by 10/10. And the result was negative 133/30, or negative 4 13/30. Either answer would be okay. Now, using division to solve, right, that means that my variable is going to be multiplied by some value. And so to solve it, I'm going to be using division, right? So if I look at number 1, this is negative 3 times a variable times something. So I'm going to use divide. Right? So when I use division, right, 1.5 divided by negative 3, my value for x is going to be negative 0.5, right? And if you recognize, that'd be the same as negative 1/2. But this, since I'm dealing with decimals in the problem, that's most likely how you're just going to leave your answer. Number 2, I have my variable over here times negative 3.1. So I'm going to divide both sides by negative 3.1. All right, so when you divide the negative 4 by negative 3.1, should be positive, right? Negative over negative is a positive value. Your calculator will tell you 1.29. So we're going to round that approximately 1.3. Number 3, it's 9.3 times my variable, so I'm going to divide both sides by 9.3. And we should get a, calculators say 0.75, depending on how they tell you to round that. If they say round to the nearest tenth, we would say 0.8. All right, solving equations using multiplication. And I'm first going to show you how it's related to division. If we look here, this is really 2/5 times x. So maybe saying, well, we should divide both sides by 2/5, right? And I'm going to write it like this so we can see. But if you remember, when we divide by the fraction, right, we leave the first fraction the same and we flip the second fraction to multiply. So if we look here, 10 times 5 is 50. 1 times 2 is 2, so we would get 25 for our value here. So when it's a fraction out in front of the variable, we can use multiplication, and we'll just multiply by the reciprocal, meaning we're going to flip the fraction, right? So if I do this on both sides, and here's why, right? Remember, fractions we multiply straight across. So 9 times 7 will be 63. 7 times 9 is 63, right? So those cancel. That leaves me with 1x. And then over here, 2 times 9 is 18. 1 times 7 is 7, right? So I can leave that as 18 over 7. Or 7 goes in there twice with 4 out of 7 left over. So take a minute and see if you can do number 3 and number 4. All right, pause the video here and then check back for your answer. All right, and number 3, we're going to multiply both sides by negative 5 over 4. And you might say, well, the 4 was negative. It doesn't matter where you put the negative. You just have to multiply so it's equal to positive 1, right? So negative times negative is positive. And it doesn't matter if I have the negative with the 5 or with the 4. Just note that it's all going to be negative as a value. So negative 15 over 28. If you have 15 over negative 28, same thing. All of these, right? If you put the negative out in front, right, that's the same thing. 15 over negative 28. These are all the same exact solution, right? A lot of times the answer key will put it like this, just showing that the value itself is negative. In number 4, you should multiply both sides by negative 9 over 2. Okay, and note that negative times negative here is going to give us a positive value in the end, right? 9 times 1 is 9. 2 times 3 is 6, right? That reduces to 3 over 2. Or if you write it as a mixed number, that's going to be 1 and 1/2. All right, you can see your practice problems here on page 245, 14 to 40 even. If you review 41, 50, 56, and then 62 to 64. So on a separate sheet of paper, do those, and then you can use the answer key to check your work. Have a great day, and we'll talk to you soon.